Good day, everybody. So welcome to a quick little online lesson. I know this isn't the best way to learn stuff, but it's better than having to do it on your own. So we are going to be going over 2.1 complex numbers, okay? Complex numbers. These get a little bit weird because we're talking about something that technically doesn't really exist, but it's something we have to deal with at times. So we're talking about what's called the imaginary unit or the imaginary number. As you should know, the value of 3 squared is 9. So also is the value of negative 3 squared 9, because both of these are 3 times 3, which is 9, and negative 3 times negative 3, which is also positive 9. Okay? So if 3 times 3 is 9, and negative 3 times negative 3 is 9, then the question becomes, and if the square root of 9, the question of what the square root of 9 is, that's saying what numbers did I multiply to itself to get 9? Well, the answer could be I took a positive 3 times a positive 3, or I took a negative 3 times a negative 3. The answer to the question, what do I square to get 9, is both plus and minus 3. But then the question is what is the square root of negative 9? Okay, so you cannot say it's 3. You can also not say it's negative 3. If you say it's 3 times negative 3, well, that's negative 9. But this is not a square. This is not a square. Okay, 3 multiplied by negative 3 is not a square. So this does not equal 3 squared. It also does not equal negative 3 squared. Okay? So you cannot say that 3 times negative 3 is the answer, because that's not a square. However, mathematicians do run into this kind of a number at time to time. And we have to figure out a way to work with it, even though it technically doesn't really exist. So what we're talking about is the square root of a negative number. We call this I. Now, if you look at this, the I is kind of written more like almost a J. It has a tail to it. Okay, I is the value of the square root of negative 1. The reason we put a tail on the I is because you don't want to just put a I and then that, because then all of a sudden it looks like the number 1. So we put a tail on our I. Now, here's the reality. This is the definition of I. I is the value of the square root of negative 1. That's what I is. And if I was to square the square root of negative 1, the square of the square root of negative 1 is negative 1, because the square and the square root undo each other, leaving you negative 1. So that is the two definitions that you need to know. I squared is negative 1, and I is equal to the square root of negative 1. So let's see how we use this to simplify a radical. I have the square root of negative 25. The first thing I want to do here is I want to rewrite this as negative 1 times the square root of 25. It is the square root of negative 1 multiplied to the square root of 25. But what is the square root of negative 1? Well, that's I. And what is the square root of 25? Well, that's 5. Now, generally speaking, we write I times 5. We put the I behind it. We call that 5i. I times 5 is 5i. So this would be the same thing. We can separate it to the square root of 16 multiplied by the square root of negative 1. The square root of 16 is 4. And the square root of negative 1 is I. So the square root of negative 16 is 4i. Same here. We can write this as the square root of 49 multiplied by the square root of negative 1. The square root of 49 is 7. And the square root of negative 1 is I. Now, A new system of numbers is created when we add together a real number with multiples of the imaginary unit. We can call this A plus BI, where the A is the real part. This is a real number. Okay? A is a real number. And the BI part, this whole part here, is the imaginary part of the complex number. The BI is the imaginary part. So if I was to give you negative 4 plus 6i, negative 4 is the real number, negative 4, and 6i is the imaginary part, that is 6. If I was to give you just the number 2i, well, that means I really have 0 being added with 2i, and 0 is your real part, and 2 is your imaginary part. And if I was to give you just the number 3, that means 3 is your real part, and 0i is your imaginary part. Adding and subtracting together complex numbers. You add and subtract these just like you would any other variable. You add and subtract like terms. So I is going to be a like term with 4i. 7 is going to be a like term with the 5. So this is, you really don't need the parentheses. It's 5 being added with 7 minus 11i, which is being added with 4i. 5 plus 7 is 12. Negative 11 plus 4 is negative 7i. So the combination of those two numbers is 12 minus 7i. What if I was subtracting? Well, you would distribute the minus sign like you normally would. And you'd have negative 5 plus I plus 11 plus 6i. Now I gather together my like terms. My like terms are the real parts. Negative 5 plus 11 is 6. And the imaginary parts. 11, just single I, plus 6i is 7i. All right, now we can flip our paper over and continue working on this. So now I'm doing the product of complex numbers, multiplying complex numbers. I'm going to distribute just like I always would. 4i times 3 is going to be 12i. 4i minus 5 times a negative 5i is going to be a negative 20i squared. But remember, earlier we said I squared is equal to negative 1 squared, which is equal to negative 1. I squared is the same thing as negative 1. So anytime you have I squared, I'm just going to replace it with negative 1. So 12i minus 20 times negative 1. A negative 20 times negative 1 is a positive 20. And we normally put the real part first and the imaginary part second. 20 plus 12i. Then we go over to this one. We're going to have to double distribute. So 7 times negative 2 is negative 14. 7 times negative 5i is negative 35i. Distribute negative 3i. Negative 3i times negative 2 is positive 6i. And a negative 3 times a negative 5 is a positive 15i squared. Again, I'm going to replace I squared with negative 1. So I have negative 14. Negative 35i plus 6i is negative 29i plus 15 times negative 1. 15 times negative 1 is negative 15. And negative 14 minus 15 is negative 29 minus 29i. Dividing complex numbers by using the conjugate. Okay, the conjugate is the opposite sign of this denominator right here. So I'm going to multiply the top and the bottom by the conjugate of the bottom, the denominator. The conjugate of 2 minus 5i is 2 plus 5i. So I'm going to take 7 times 2, which is 14. I'm going to take 7 times 5i, which is 35i. I'm going to take 4 times 2, which is 8i. And I'm going to take 4 times 5, which is 20. And I times I, which is I squared. Now the power of the conjugate is the middle two terms here. If I do the bottom, if I take 2 minus 5i times 2 plus 5i, these two middle things are going to add to 0. One of them is going to be positive 10i, one's going to be minus 10i, and they're going to go away. So 2 times 2 is 4. And then all I got to do is take negative 5i times 5i, which is negative 25i squared. Replace my I squareds with negative 1, add together like terms, and you get 14 plus 43i plus 20 times negative 1 divided by 4 minus 25 times negative 1. Negative 1 times 20 is negative 20. Negative 1 times 25, negative 25 is positive 25. 14 minus 20 is negative 6 plus 43i divided by 4 plus 25 is 29. So this complex value simplifies down to this one here. Same idea. Conjugate is going to be 3 minus 4i. 3 minus 4i. 5 times 3 is 15. 5 times negative 4 is negative 20 with an I. Negative 6 times 3 is negative 18 with an I. A negative times a negative is a positive. 6 times 4 is 24. I times I is I squared. 3 times 3 is 9. Positive times a negative is a negative. 4 times 4 is 16. I times I is I squared. Now we're going to replace all I squareds with negative 1. And we're going to combine together those that can be combined. So it becomes 15 minus 38i plus 24 times negative 1. All over 9 minus 16 times negative 1. Negative 1 times 24 is negative 24. Negative 24 plus 15 is negative 9 minus 38i divided by negative 1 times negative 16 is positive 16. 16 plus 9 is 25. Negative 9 minus 38i divided by 25. All right, last, how do we deal with, multiplying square roots together that have a negative in them that haven't yet been changed to i's? Here is the rule. When performing operations with negative square roots, you must always first transform into an imaginary unit first. Okay, so if I have the square root of negative 25 multiplied by the square root of negative 4, I must first take out these i's because this is an imaginary number, and this is an imaginary number. And you got to take those i's out first, then you can multiply by these two things. The square root of 25 is 5, the square root of 4 is 2. So this becomes 5i times 2i, and 5i times 2i is 10i squared. Replace the I squared with a negative 1, and you get negative 10. If you do this right here, and you multiply them first, then all of a sudden you have a negative times a negative, which is a positive, and then it becomes a positive 10. This is incorrect. You cannot do it this way. You must first take out the I. So, here we go. First thing I need to do is rewrite this as negative 1, times. Now, 18 is the square root of 9 times the square root of 2. Then I have minus I. Square root of 8 is the square root of 4 times the square root of 2. Now, why did I change this to 9 times 2? And why did I change this to 4 times 2? Because 9 is a perfect square. 4 is a perfect square. They go into 18 and 8 evenly, so I'm reducing the radical. The square root of negative 1 is called I. The square root of 9 is 3. The square root of 2 stays the square root of 2. Minus, square root of 4 is 2. Now I'm going to rewrite this a little bit because we generally write it 3i, put the radical at the end. 2i, put the radical at the end. Now, the radical is exactly the same. I have I root 2. I have I root 2. So I can subtract these. 3 I root 2's, take away 2 I root 2's is 1 I root 2. Try it again. I'm going to first take out the I. So this is negative 1 plus I square root of 5. I'm squaring this, so that means I'm multiplying it by itself. I would suggest writing it out twice. Negative 1 times negative 1 is positive 1. Negative 1 times I root 5 is negative I root 5. I root 5 times negative 1 is another negative I root 5. And then I times I is I squared, and square root of 5 times the square root of 5 is just 5. I root 5, negative I root 5, minus I root 5 is negative 2 I root 5. I squared is negative 1, and negative 1 times 5 is negative 5. And 1 take away 5 is negative 4 minus 2i square root 5. I have negative square root of 50. I'm going to take out the I. I'm also going to reduce the radical. Negative 25 plus I times the square root of 25 times 2. 50 is 25 times 2. So I'm going to write this as the square root of 25 times the square root of 2, divided by 15. So then I have negative 25 plus the square root of 25 is 5. 5 times I is 5i, square root 2. But what goes into 5, 25, and 15? The answer is obviously 5. So 5 goes into 25 5 times. 5 goes into 5 once, leaving just I root 2. And 5 goes into 15 3 times. All right, last problem. And this one will probably get a little bit, pay attention, okay? I'm doing also some algebra review here, okay? We have a quadratic. We are going to solve this quadratic. I'm going to solve this quadratic by completing the square. You probably have seen this before. You should have seen this before. Completing the square. So, in order to complete the square, the number that is being multiplied to the quadratic, the coefficient of your quadratic, that must equal 1. Right now it equals 3. So I have to divide everything by 3. Technically speaking, you're also dividing the 0 by 3, and 0 divided by 3 is 0. So this becomes x squared minus 2/3 x plus 4/3 equals 0. Now to complete the square, I'm going to prep it by moving the constant to where the 0 is by subtracting it. So I'm going to say x squared minus 2/3 x plus something is going to equal negative 4/3 plus that same exact something. So I'm going to put something in this spot right here. It's going to make a perfect square. This is the thing that completes the square. If I put it here, I must also put it there as to not change the equation. So the question is, what is the thing that completes the square? Well, you look at your b value. You look at the coefficient of your x, your linear term. This b value is negative 2/3. You take half of the b value and then you square it. So the thing that is going to complete the square is the b value divided by 2, which is multiplied by half, squared. Well, 2 divided by 2, those go away, leaving just 1/3. 1/3 squared is 1/9. So the thing that completes the square is 1/9. Now, you have made a perfect square. This thing here is a perfect square. It will always be a perfect square because you completed the square. You forced it to become a square. The square that it is going to be is always going to be a single x. Whatever this sign is, this sign right now is a minus sign, and the number that you squared to get 1/9. What number did I square to get 1/9? Well, 1/3. X minus 1/3 squared is x squared minus 2/3 x plus 1/9. Well, what does this equal? Well, it equals negative 4/3 plus 1/9. Multiplied by 3, get a common denominator. The common denominator is going to be 9. 4 times 3 is 12. It's negative 12 plus 1, which is negative 11 all over 9. Now, how do you finish solving this for x? This is why it's showing up in this complex number unit. I solve a square by taking the square root, as long as it's just this whole entire side is being squared. So I'm going to square root this entire side. If I square root this side, I'm going to square root this side. If I square root this side, don't forget your plus and the minus. So now I have x minus 1/3 is equal to the plus and minus of the square root of negative 11 divided by the square root of 9, which is 3. The square root of negative 11, that is I. I can add the 1/3 over, getting 1/3 plus and minus I root 11 all over 3. Now you'll recognize these two have the same denominator. They will always have the same denominator. So you could also write it as this: 1 plus and minus I root 11 all over 3 as one fraction. Now that one, again, we're going to probably go over this one a couple more times in class and stuff. Okay, but completing the square. So I did a review of completing the square. The whole point it showed up in this lesson is because of this square root of negative 11 that shows up in that particular problem. So there we go. That is the end of 2.1. Thanks for listening.